So we've got our assemblies created. I'm going to create a folder here just to organize this. We'll call this all assemblies. If we don't organize this, it'll get out of hand. Then I'm just going to drag these over so that our previous assemblies are here and we'll know where to find them. So now let's create another folder. Let's call this original drawings. We're going to create drawings before we do the full scale connection print. So we're going to have to print off the parts for the full scale. And these are going to be all of our drawings that we create for the individual parts. Now, before we go any further, let's go back, click on the Home button. That'll take us back so that we can select what we just created. Select Part Studio if you're not already in it. And there's a few changes after small scale that I want to adjust. Let's go down to the connections. So these are our side spar, and I felt like this was really too long. So I'm going to left click on that. Double click here on the drawing. Instead of 3.5 here, it's fine on the other side. Let's go 2.5. Yeah, let's close that out. Now let's see what that looks like. That looks way better. That looks more like what I had originally. Make sure the hole stayed where it was supposed to. It did. So all it did was just shorten the length. It's still going to be 3/4 of an inch from the edge. This should be the spar hoop connection. Let's rename that. So spar hoop connections. These are what go on the outside of that spar to connect the hoop. All right, so those are the changes we needed to make. We're going to do each individual part. Right click. So let's go create drawing from part 1. It's asking us how many views we want. So you can create your own views, which is what we're going to do, or have it do it for you. Let's do each one of these. So let's go no views and hit OK. And then you notice this is not scaled in a way that it would be useful for this drawing. So let's go 1/10 scale. Let's bring this over, left click, and then hit escape. So that's going to be your front view. And this isn't going to vary much because it's just a tube. Now let's go insert view. Let's go top view. So it's just going to be a circle. We'll place that down here. Hit escape. Now, if you want to change the scaling, you can right click on this. You can view properties, left click view properties. Go down here to the scaling and change that. If you're like, that's way too small, I can't even see what I'm looking at, I'm going to go 1/2 scaling on this. And it'll tell the reader that this has changed, like the scaling is different than the other part if you change that scale from what you originally inserted into. All right, so let's go insert. Let's go find. Now you can change up the parts. We're not doing that. We're going to do one individual part. Let's change our view to right view. Let's just place it here in the center. Hit escape. Let's go insert. Let's go isometric, and we'll place that over here. There we go. And it kept that 1/10 scaling. All right, now let's do some of the measurements. We have a dimension tool, and this is already preset to just the normal dimension tool that you're used to. Left click on that to activate it, find a point that you want to measure, and then drag that out. And that gives you the length. Let's go point to point, or point to line. Let's do that. Point to line dimension. So we're going to go from this point here to that point. Now this won't be exact. It should be 4 inches because that point went from that edge. So let's undo that. Go up here to the dimension tool. I'll delete that because I don't want that one. Let's use it over here. It would be better. So this is from point to line dimension. So we go from that center point to that line should be 4 inches. Scroll back out. Now we can go line to line. Very similar to just the dimension tool. But now we're going to go from this line to this one. And that's our diameter. Let's go down to actual diameter. And it's a very similar process. So it's saying this tube, instead of selecting both of those lines, it's just saying that whole tube is 0.73 inches in diameter. Now if you have a circle, that's the reason I did top view, and you do diameter, same thing. You can also go down and do radial dimension. So I'm going to click on that the same way, and it'll give us the radius. Turn off your dimension tool. We'll use some of these other features in just a second. We'll just use the most common features. Left click on this, double click, and this will be front frame tube. There we go. And you can see your names here, your date, and what other information you want to put in there. So you could give more of a description, whatever you want to plug in. We'll just call that front frame tube. Let's call that part 1 so we can keep these in order. We can easily reference what part we're talking about since that's the way we named it in Part Studio. Left click on that, hold the left button down and bring that over into original drawings. Let's go back to Part Studio. Motor mounts, I don't think we need to do that for each part. I'm going to go in and create drawings of each one of these. And then as I get to features we haven't covered, we'll bring that into the video. We'll make a video about the features we haven't covered yet, because these are going to be really similar. Actually, let's go to motor mount. Before I do that, let's right click on that. Let's create a drawing from the motor mount. Let's do 4 views so that it automatically gives us 4 views. So you can see that other feature we mentioned. All right, so those are there. It automatically scaled it for us. I'm just going to drag these over. As you move one, the others will move. That's kind of aggravating. If you use that feature, they'll move in conjunction with each other, except for the isometric one. So as I move that over, this will move. And then you can use your dimension tools the same way. We'll use these other tools once we have something with an angle. All right, so that was the motor mount. We'll deactivate that tool. Left click here. Let's go Part 2. Motor mount tube. There we go. Close that out. And then I'll take Part 2. Let's create a drawing of Part 5. Let's go in and do our 4 views. If we don't like one, I'll show you how to change it. Now, here's the issue. If I move this around, this is why I don't often use that tool. Let's say I drag this one around, that one's going to move. We'll change it from here. So the reason I normally start off with a blank slate is so I can insert these one at a time, and then if you make an adjustment, move it around. It's not as big of a deal because the part doesn't move around. The other parts won't move around that are paired with it because there's nothing paired with it. So let's go down, let's find part 5. I probably looked right at it. Right there, there's part 5. So this is our back frame tube. We did scaling, 1/8 scaling. Let's click on that. Now it's asking us to go ahead and insert another one based on view. I don't want that view, so I'm going to hit escape and I'll just do these manually. So I can right click on that if I don't like the scale on this, because it's really the side view that I want. So I can go view properties. Let's change the scale. So the sheet is 1/8 scale. If I change anything from that, it's going to mention it at the bottom just to let the viewer know that, hey, this is not the scale of the rest of the parts on the sheet. Let's see what 1/4 scale or 1/5 scale. Let's do that because I want this to be a little larger, a little easier to read. We'll place it here. Let's go ahead and insert another part. Let's go to isometric view over here and let's just place this one. That's going to be that 1/8 scale that we used. And you notice down here at the sheet it says 1/8 scale here. I'm kind of covering it up, but down here at the bottom on scale it'll tell the reader what the scale of the sheet is. I'm going to leave that there, and I think the only other angle I want is a right view. Let's see, yeah, so that we can, no, we want left if it'll let us. Yeah, let's do left view. The reason I want that is for that circle there, for the diameter. So let's use some different tools. Let's left click here on dimension tool and let's go line to line angular dimension. We haven't used that yet. So I want this straight line here. I want this straight line here, and I want to bring that out to get the angle. So that gives us the angle of that bend. We'll need that when we're creating these parts. Left click here again. Angle of the bend before you left click. And I want line to line. I want to go from this line here this line here, and that's going to be 30.75. Let's go here to here. That'll tell us what we have at the bottom. Let's go from this line here to that line there, 1 inch. So we'll know that we'll have that much to insert. 2 point. So I want to go from this point to that point. That'll tell us the distance from there. Total length of the tube. So I'm going to go from this point to that point. I'm going to bring that out right there. Back in here, we've already done this. Dimension of the tube. We can do radial dimension if we want to again. Line, we could do that over here. So we could go from this line to this line, and that'll tell us diameter as well. All right, that gives us most of our dimensions, and then we can add the name to it. Let's turn that tool off. Let's go down. This is going to be part 5 back. So this will be our back frame tube. All right, we'll add the note. Part 7, top harness tube, and I'm going to go back in and change that other one just a sec, close that out, hit escape so I don't add another one. And I'm going to go back in here and change that one. So we got that. I'm going to right click on that, view properties. I want to change the angle. I think we were at left, yeah, close that out. All right, so that gives us top harness tube on this side, part 7 on this side, and part 6 on this side. All right, let's go in. Let's do line to line angular dimension. So 90 degrees. Do the same thing here. We'll get some dimensions. See here what the inner radius of that would be. There we go. So it gives you a radius of a bend with the normal dimension tool. Let's go down. Let's do radius here. Let's do radial here. Same thing over on the other side. Wrong one. So now let's look at the total length. Let's go line to line. Let's go from here to there. Same thing on this side. And if this is in the way, close that out and we can move this up here just so that it doesn't look so messy. 2 inches here so that we'll know the diameter. I'm going to move that scaling over here so it's not so messy on this side as well. And we can do the same thing over here and get the diameter so that we have that, because they're essentially the same part. Let's not do 1 to 1. Let's go 1/8. Let's see what that looks like. That looks good. Hit escape. Let's go insert. Let's go isometric. Let's see what that looks like. Let's put it over here. It's not going to look much different, but at least we can see the differences between the two. So let's look at diameter. So let's scroll in here so we make sure we're selecting the right line. So we want this inner line. Go over here, select the outer line. And you notice that these are different. It's because we would have to take the average of these to get to 56 inches for the diameter of the hoop, because it's giving us the outer diameter and the inner diameter. We can also go to radial dimension. That's useful here. And the same thing applies, where we would want to select both sides and then take the average of those two. Let's go dimension tool. Let's go from here to that point, and it's telling us that is 28 there, which is our radius. So let's do 3-point angular dimension. Let's go here, here, and here. There we go. So that's telling us this is 90 degrees, like a 90-degree segment. That's what we want. That's going to be useful if we're doing the arc length. Turn that off so that we can move this around so it's easier to see. So that would say this is a 90-degree segment of 360 degrees. A dimension tool here and here just to get the diameter of the tube itself. Let's change that view to right view. There we go. That'll give us a better estimate of if it's going to fit on there. All right, let's close that out. It's good there. And I think this will give us enough measurements. Let's go in. Let's do our first dimension tool. If we go from here to there, it'll tell us the length. We're probably going to need another one of these because it'll get messy. 7 inches there, 5 inches here. And then that would tell us from here to here, we got 1 inch. All right, good enough. Right click on that, view properties, and let's do the same angle here. Let's do front view at a quarter scale. Should have just made the whole sheet a quarter, and then we wouldn't have that little note, but that's okay. Close that out. The reason I want 2 is I don't want it to get too messy. We've got our dimensions up here. We'll go ahead and finish those out. Like if I went to line dimension, I could get an estimate of length on that. We could go back in. Let's just use this one to get an idea of length. So let's go 2 points here. And that'll give us an idea of the length of this tube needed. We could add these up and get a rough estimate. The reason I wanted to create another one is now we can go line to line angular dimension. That'll give us an idea of degree of bend on each one of these. And I'll do this one here too, if it'll let me highlight it. I don't want that. Highlight there. Oh man. Let me zoom in so that'll be easier to select, and then there. So that gives us an idea of the degree. Our radius of the bend, we could come up here and do radial dimension. I'll move that around in just a sec. It's going to be 1. Remember when we created this, we did radius of the bend at 1, but we're doing the inner portion and outer portion of that tube. So let's just look, let me turn that off for just a second. Let's look at these two numbers and I'll show you exactly what I was talking about. So if we go 1.365 plus 0.635 equals divided by 2, we're going to get 1. All right, so that looks good. I don't want it to get too messy and put too much on there. If we needed to do another distance, like if we want to know how far apart or the diameter of that hole, for drilling, again, we just go diameter. That tells us that that is 0.314. I believe that's an 8M8 bolt that would go through there. Here, I can get a dimension of length. I could go in and do diameter of the tube. Remember we did those at 0.77 just so they would slide on easier. We could go in and do point to point, so 2-point linear dimension. Click on the center there, get an idea of the distance between those two. And this can get messy real quick. We just did the engine mount plate and we had to create 3 different views because it was getting really messy. So we had to do the outer bolt holes. I'll just show you. We just created that. So we did these outer bolt hole measurements first from each edge. So we did our outer dimensions of the actual plate itself here. We did the width of the plate here. And then we did the engine mount, where the engine mount, we did the bolts where the engine's going to mount, and we had to label these so that we had an idea because it got really messy real quick. So we're going to do inner diameter here. We're going to select the outer part here, and you can do that for each. It would probably be better to find the angle on this one. So we know that one's 158. There's another part with an angle. So we really want to know the angle. So when we set this, we set it based on this tube here and this tube. So that's the angle we're looking for, 157. So this is our hoop for assembly view. And it's not an actual part that we printed off or anything, but it is useful for dimensions. So we can go out here, inner, outer diameter. Those would be averaged. It's good just to get an idea of total size. So this is our radial dimension for both of these, inner and outer. And again, we take the average between those two. We can do the 3-point dimension. When you select 3-point angular dimension, I don't think I talked about this in the last video. The order that you do this in is important. Yes, is important. So I did center, outer edge, and then the second outer edge. And what that's going to give me is the degree. That's going to be useful for arc length to determine, based on that angle, what's the length or estimated length of that tube. We can plug it into that formula. It's a different size than the top hoop segment. This is the bottom hoop segment. So we would take those two, average those together. That's our diameter. I'm going to turn that off and just move those down here so that they're out of the way. So we have to average those two to get the true diameter. Again, useful in formulas and estimating length of tubing needed. We'll go down to radial dimension. We'll place it here. We'll do the outer one. Then we'll go back and we'll do our 3-point angular dimension. The order that you do this is important, so we're going to select right here, here, and here. 68 degrees is what we would need for our formula. If we plug this into arc length, we would also need diameter or radius, depending on which formula we use. Original drawings. And we go in, I'm going to scroll across. You see these arrow keys on the far bottom right hand side. Notice we go from part 1, part 2, part 3, all the way through all those parts. Some of these parts that were similar, so part 6 and 7 were like that. I just renamed those to represent it. But we have all of our parts together. Same thing for part 17 and 18. Very similar parts. We had a mirror image, so I just included those because they would have the same dimensions. And even the hoop segment for assembly view, it was included. But those are our parts. And you can see why I put those in a folder, because if we had those in our original document, it would get very confusing having all those laid out, trying to navigate, going to the other assembly views. But by placing everything in a folder, same thing for all of our assemblies, it allows you to kind of organize your workspace so that it doesn't get away from you. Now, the reason we did the drawings before we did the full-scale assembly and before we printed off the full-scale connections, so we needed to see if we needed any changes, plus we can print these drawings off and or pull them up on a computer. Either way, I've done both. And as you assemble it, if there are changes that need to be made, you can make those real time. If you need to see where the bolt holes are drilled, what's the actual length of the tubing that you need to cut, these drawings are very important for that stage of the process. Not only recording changes real time, but also being able to see your measurements. So right click on your part, let's just do part 20 since we just finished with it. Go export, and very similar to exporting a part, but now we're going to be exporting as a PDF, and hit export. And then it downloads, and then once it downloads, you can go to that location, open that up, and save all your drawings in a folder. And that's exactly what I'm going to do. I'm going to export all of these out and save those in a folder, and then we can print those off so that we don't have to take our computer out into our shop and risk damaging it there or getting it dirty.